In the previous video, I showed you how to use graphs to solve something complicated like this. So here, to solve this, you would start by sketching the graph. So when x is small, well, you would start by sketching the graph. So this is one line. Hang on, and then the other one is y equals x to the power 3. So it's something like this. Okay, like this, and it crosses here and here, because you don't know the scale here, then you would create a table like this: x, and then you would guess 0, 1, 2, 3, 4, 5, 6, and so on, and then until you find out the point at which the two lines cross. Okay, so we did that with so this is what the graph actually, the two graphs will actually look like. And then we created a table to find out where the two lines cross. So we didn't have the scale along here, so we would just guess, like start with 0, 1, 2, 3, and so on, all the way up there, and then we found out that the two graphs crosses somewhere around here. Okay, and then we would zoom in. So because we know it crosses between 1 and 2, then we would recreate a table, and then we start at 1 and then we end at 2, and then just split it up in between. And then by looking at this, by looking at these four figures here, we found out that the two lines cross in between these two. Well, in between 1.3 and 1.4. So a good guess would be 1.35. So we guessed x to be this. So this point here, we guessed it to be 1.35. Now, if you look at this our original proper graph here, there's another solution here. So I'm going to cheat. It's between 0 and 1. But if you were to do this by sketching, you wouldn't know it. You wouldn't know it's between 0 and 1. So if you were to sketch this, it would look something like this. Hang on. It would look something like this. And then y equals x to the power 3 would look something like this. Hang on. Something like this. Now, if you were to sketch this, you wouldn't know this would be between 0 and 1. So you would really jump to a table like this. X equals this is x. Hang on. So this is x and this is y. You wouldn't know it's between 0 and 1. So you would do this: 0 minus 1 minus 2 minus 3 minus 4, and so on. And then find out where the two this is x to the power 3. This is 1 over x plus x squared. You would do this and then find out where the 2 points cross. But because so let's just take it as between 0 and 1, because we kind of cheated. But if you were to sketch this, then you would do this, and then you would notice that the two lines would cross between 0 and 1, and then you would zoom in. Okay, zoom in between 0 and 1. So let's just say we know it crosses between 0 and 1. Okay, so let's zoom in now. So we are trying to find out this point here. So we know it crosses between 0 and 1. So we would create a table, a new table like this. We know it crosses between 0 and 0 and minus 1, not 1. 0 and minus 1, and then you would do then you would, well, okay. So here we've got this here, plus x squared, and then over here we've got y equals x to the power 3. Okay, so we've got two lines here. Now, in order to look at this, we know it crosses here. So we started with 0. We started with x equals minus 0.1, so it's here. Okay, negative 0.1. So we would put negative 0.1 into here, and then negative 0.1 into here. So in effect, it would be this: 1 over negative 0.1 plus negative 0.1 squared. Okay, so here well, anyway, if you work out this whole thing here, it will come to this. Okay, and then if you put minus 0.1 into here, it will come to this. Now you can see that the red line here is a lot further. Well, when it's at 0.1, is a lot further below the blue line. So let's start again here. Okay, so when x equals 0.1 here, 0.1, let's say it's somewhere around here. You see, the red line is a lot lower than the blue line. So the red line here is a lot lower than the blue line here. Now, if you look at minus 0.2, 0.2, you see the red line here is still a lot lower than the blue line. So this is the blue line here, and this is the red line here. The red line is a lot lower than the blue line. Now let's look at negative 0.3. When x is negative 0.3, the red line here is a lot lower. Well, it's not that much lower, but it's quite low. It's lower than the blue line here. Now look at x equals minus negative 0.4. The red line is lower than the blue line. Okay, so the red line here is a lot lower than the blue line. Now, if you look at 0.5, the red line is still lower than the blue line. So the red line is still lower than the blue line. Now, if you look at this here, the red line here is still lower than the blue line. The red line here is still lower than the blue line here. Now, if you look at, let me clear this. Now, if you look at the 0.7, the red line here is still lower than the blue line here. Okay, but the thing is here, here the red line, when x equals negative 0.8, the red line here is still lower than this line here. The red line is still lower than this line here. But then if you look at minus 0.9, you see the red line here is now above the blue line. So around here, the red line here is now above the blue line here. So there must be a point at which you know the two lines cross somewhere in between. Okay, so hang on. So at minus 0.9, the red line is the red line is above the blue line. Okay, at 0.8, the red line is below the blue line. So the two must cross somewhere in between. It must cross somewhere in between here. So we can guess that x equals, I'm going to take the midpoint of the two. So negative 0.85. So here we would guess x to be this. Okay. Yeah. So that's how you do it.